So look at what the cat dragged in or pushed in. Get it? Caterpillar, forklift, dragged. Anyways, you get it. So if you are new to the channel or if you were just waiting for this build to come back, I'm going to give you a quick rundown through it. But essentially what this is a 1980s, 1970s Tirajet. Now, of course, we've made some drastic modifications to it. The original Tirajet never came with any suspension whatsoever. It was just all tires for your suspension, but they were amphibious. So the main goal with this build was to have long travel, long control arms, long suspension, long travel suspension, independent suspension, any type of suspension at all. This is what we were going for, but we wanted to keep it amphibious. I wanted to maintain amphibious capabilities so that way if we came to a pond, lake, river, whatever, I could kind of traverse across it if need be. We're not making a boat on wheels, but we are making a buggy that can float. So I've been looking at the analytics on YouTube Studio, and it's been about a year since I've done any drastic work or I've uploaded a video on this thing. And I can't believe I let it sit that long, to be quite honest with you. Now, in the last video, once again, which was like 11 months ago, I was having an issue with bad bump steer, trying to figure out the steering on this thing. And essentially I was having a lot of trouble with the suspension, especially up front. Who would have thought that a guy that never done any suspension work would have fucked it up? But anyways, here we are. So as you can see, one of these things are not like the other. Over here is our original side that I kind of done, once again, 11 months ago. This is what I done probably about a week ago. And I think this is going to work in our favor. I'm kind of glad I went this route. And I'm going to bring you guys along with me today to do that side and mirror this side. But first, what I want to do is take this body off. I want to show you exactly everything I've done on this side so we can just kind of mimic the same thing on that side. All right, guys, so as you can see, we took our body off, we got our two shocks removed along with our rims and tires. And I kind of want to give you guys a more in-depth view of essentially what I was working with as opposed to what I've done to kind of fix a few issues here. Now, one thing we have to realize is that I utilized a lot of parts off of a donor UTV. And if I would have used the same geometry, these ball joints, this spindle, everything probably would have worked out pretty good for me essentially. But where I've tried to get so much travel out of this, where I've tried to jack the body to get a bit of ground clearance, this ball joint, this spindle is just no good for this application. I've kind of maxed out these ball joints. Not that there's anything wrong with ball joints, but this drastic of an angle, the geometry, it's not the right way to do it. So what I really want you guys to focus on here now, where we're having the issue, I laid all this kind of back together. This is what I kind of done with the steering linkage, just trying to get this thing to turn properly. I've gone a different route with that as well that I hopefully we will get to in this video, but this is essentially scrap right now. I just want to show you guys what the issue was with this setup. So essentially where this is so long, where our ball joints are maxed out, where our spindle is so short, through our suspension range, it wants to take our flange and our tire and our spindle and shove it out this way. That was giving us insane bump steer to the point that nothing would ever handle how bad of bump steer. Would just break parts, it'd twist shafts. It was just a very, very bad design on my part. So what I want you guys to kind of notice is that this is full droop. This is as far as our CV axles will allow. Right now, our CV axles are actually binding because this is just too drastic of a drop for these CV axles. But for the sake of the video and the sake for information, I want you guys to kind of focus on this flange. Essentially, this is where your rim bolts to, your tire sits here. So as I come up through the suspension stroke, you can see just with everything laid together, this is just very loosely laid. You can see the issue we're having already. Essentially, this spindle wants to kind of turn in as it's coming through the stroke. So that was giving us bad bump steer. And when it was connected to the other side, it was essentially just solid. It wouldn't move because everything was binding so bad. But even this way, if you take a look at the top of our flange, you can see that it really wants to go out. It really wants to shove out. Essentially, the bottom of our wheel is in here now. Top of our wheel is out. So you see how drastic that is. Another thing as well, let me just get this out of the way. We'll touch on the steering and what I've kind of got in my head for that later. But another thing I wanted to touch on as well, the way I have this lower control arm, it's bonded into our inner CV axle. So I actually had to modify the lower control arm over there as well, which I'll walk you guys through in a moment. But you can really see how drastic that is, and you can really see how it would be a really bad bonding issue. And of course, with this spindle being the way it was, even if I did get this to work, check out where our end link is actually located. I mean, it's just absurd. It was just the wrong application for what I was trying to achieve. So let's jump over to the other side and I'll run you through that. All right guys, so we are on the other side of the machine, and as you can tell, there's probably a few key differences that you're kind of cluing into right out of the gate. First and foremost is this spindle. Now this is kind of the key factor to making all this work. I designed all this to utilize the factory bearing carrier out of our UTV spindle. I'll touch on that a little bit later in the video, how we modified that to make that kind of work. This spindle actually allows me to do a couple things, fortunately enough, that we can use harm joints, so that way I have kind of infinite range as opposed to ball joints. Being able to utilize the harm joints, it gives me adjustment because these things are threaded. They have a threaded insert, so I can adjust that spindle in and out as I see fit. As well, the spindle actually allows me to sit this upper control arm flatter. Now what that allows me to do is have better geometry. As you can see on the other side, this one was kind of drastically down. So as we were coming up through that suspension stroke, it was trying to push the spindle out before it would come up and find that real nice curvature in the suspension travel. It was kind of just non-existent over there, unfortunately, and that's why that whole flange kind of kicked out really bad before it actually started to come in. The other thing that I decided to do on this side as well is that I've cut out a portion of my lower control arm. Essentially that gives me the opportunity not to bind in against my inner CV axle. It gives me a lot more travel. In the future, I think what I'm going to do, I actually left quite a bit of meat on both sides of my lower control arm because I want to come in there with a pipe, probably create like a little bit of a U shape on the bottom right here. That way if I do roll over some sort of stump or anything like that, it'll kind of just deflect off it as opposed to sticking up, probably tearing our CV boot. Plus, on the other hand, it may just tighten that lower control arm up quite a bit where I have this center cut out. Not that I think that that is not strong enough now because it's really overbuilt. It's braced inside. But, you know, we're gone this far. We've overbuilt this far. We might as well keep overbuilding. So by allowing this upper control arm to lay flat, I had to adjust my shock hoop. So essentially, I just made it taller. I've kind of changed the location down here. Of course, we're going to have to brace this now because it's quite a bit taller, so I may end up running over here to the other one. This buggy may, in well fact, get a full roll cage in the future, so I'll tie it all together somehow, but once again, that's in the future. Now, I wanted to maintain my lower mounting point on my shock to my upper control arm, just because I felt that if it's up here, it's out of harm's way, and it'll just be a little bit safer. With all that being said, I really want you guys to focus your attention to our flange and what it's actually doing during our suspension stroke. Now, of course, this is at full droop. It's actually bonding, so it will never get this low. The shock will take up all the weight before it gets this low into its suspension travel. So I want you guys just to take notice of this and just kind of compare it to what the other side was doing. So as you can see through its whole suspension stroke, you'll never be able to get this far up into your suspension stroke just because the shock will never allow it. I mean, what's that, 6-8 inches? Your shock will never compress that much. But I want you to notice the flange. It doesn't kick out. It stays pretty straight. It does kick in a little bit through its range up here, but that's going to work in our favor because essentially when we put our end links in, our end links will hopefully follow the same geometry somewhat. It'll just work a lot better. Hopefully there will be no bonding, no bumps there, and we can make that work. So what I think we're going to do right now, we're going to jump over back to the other side. I'm going to take that spindle off and we're going to modify it and start making this other spindle for the other side. So as you can see via the time lapse, I came in here and I cut everything off with our portable bandsaw. Now what I'm going to do, I'm going to kind of clean this up a little bit with our grinder, and then we're actually going to put this in the lathe and turn it down a little bit. just took essentially the most meat of the material with the grinder. Now I'm going to just take it with the lathe. We don't really have to go this far. Realistically, if I wanted to just kind of bury all this within our spindle, you would never see it again. But since we're gone this far with it, I'm just going to turn it down with the lathe. That way it'll be a nice material to start with, nice and clean to work with, and it'll get rid of a little bit extra weight, I guess, more than anything. But it's probably a step you don't really need to take. And truth be told, if I wanted to just spend a little bit more time on the grinder, I probably wouldn't have to use the lathe at all. But I'm very novice with the lathe, and I kind of try to use it whenever I can, just to kind of get a better feel for it. Not bad. So there is what we have to work with. Kind of, it's not perfect, but it's a lot better than what it was. Sorry about the compressor in the background, but as you can see, we have our CAD loaded up for our spindles. We have our sheet metal plate. This is 1/8 thick mild steel. As you can see, this is our 2 tabs. I'll walk you guys through it when we tack it all up. Just some filler pieces, some supports. Once again, there may be some trimming that need to be done with this while I'm fabricating it, but this is essential, the main structure of it. So now that we have everything loaded up, go to work 0. Let's hit start and let's let it cut. So now that we have our parts off the table, guys, as you can tell, has to be cleaned up. They're full of water and whatnot before we may weld these together. So what I've always done, especially with smaller parts like that, they're really hard to hold on to. So all I've ever done, I picked up one of these cheap magnets off Amazon. And essentially this is a steel fitting table. So I'll come down here. Put that underneath, so now all these little pieces won't go flying when I'm grinding them. Next part of the build process, now that we have these cleaned up, is we're gonna have to bend these. Essentially we need to get a certain angle on them just to kind of kick out around our tire. It'll make sense in a bit, I promise. Actually went a little bit over. Now this angle is actually from our other side. We know how to get this angle because, well, I've already done it. So a little bit over. What we're going to do is flip that back over. Just kind of give it a little bit of tension. You can watch this build series on this whole hydraulic brake on the channel actually. Anything to say now, it needs a little bit more. It's perfect there. This one could go a little bit more. May not be $100,000 or $200,000 brake, but hey, does the job. So I went ahead guys and burnt all this in while my camera was charging. It was actually really low. So we still need to do quite a bit of cleanup onto it, but for mock-up purposes, I think we're right where we need to be. There's a couple little other tabs right here that I've yet to burn in, just because I like checking to see if this is going to bond or if it's going to hit up against it. Should totally be fine because the other side was fine. Essentially this is just a copy of the other side. So I think we will be fine, but I'm going to wait till a little bit later to burn those in. So I actually think what we're going to do now is take the upper control arm off and modify that to accept our arm joints. So I went ahead and I took our upper control arm off, just took the saw, put it in the bandsaw, and let it cut that ball joint off that I had welded on in there. Also went ahead and just broke these tabs off that were the lower mounting points for our shocks. Then I went ahead and we cut these 2 pieces of pipe at 2 inches long. And what that's going to allow us to do is take our arm joints, slide in there. We got a really nice seam or joint to put a nice bit of weld on. I can then come in and drill a hole on both sides here, and we can plug weld. Then what we're going to do, I'm actually going to notch out this control arm on the bottom right here to accept our arm joint, sink that in about halfway, end cap it, and I think that'll be plenty strong. That's what I've done on the other side, so just like Groundhog Day really. So I actually went ahead and cut these shock tabs on the CNC table. These are going to be the lower mounts for our upper control arm. This is essentially where our shocks will mount on that upper control arm. So I'm just going to put a little break into them. Now these are 3/16 thick, so they're a little bit thicker than probably needed, but hey, whatever. Just going to put a couple degrees into them, nothing too crazy. So what I've actually done here, guys, with our two tabs, once again, these are made of 3/16 mile steel material. I actually took the bushing out of the shock eye out of one side, and then I put 1/8 of an inch washer here on one side. That way it's going to give me a little bit of a leeway there if something does twist during the welding process. But that's essentially how that goes, just like that. Now you can kind of see why I put that bend there. Pretty much I put those bends in there just because, well, it kind of looks a bit cool, and it kind of puts this much weld out here on the side of our control arms. That way it's a bit strong. Now with that being said, I believe I do, if I remember correctly, when I made these, I think there is a piece of flat bar this way, piece of flat bar that way. So it is plenty strong. If I feel like it's going to be weakening in the future, I could always just put like a gusset plate or a fish plate. But so far, so good. I'm going to go burn those in now, and that'll be it for our upper control arm. So here is our upper control arm with our shock tabs along with our spindle. So we're moving right along. We may as well just take the bottom one off now, get that one finished, then we're going to have to move on to the hoop. Yeah, still a little bit of work left, but I'm happy with how that's all coming out. Of course, like I say, these arm joints have quite a bit of adjustment. Now I don't want these threaded all the way out, so I'm trying to keep it within reason, because you don't want just 2 or 3 threads holding this arm joint on. It's just going to be a very, very weak point, even with the lock nut. So trying to make sure, I don't mind, 5 or 6 or 8 threads showing. That doesn't really bother me too much, but the more threads that are kind of inside, the beefier it is. Let's jump right in and take this lower control arm off. Took the lower off. As you can see, this is where I'm going to end up cutting this piece out, just to give us enough clearance for the CV axle, that inner CV axle, to kind of sit in there and not bind up against anything. So we're going to go ahead and cut that piece out, and then we're probably just going to patch it in yet again, and make that thing solid. And like I say in the previous part of this video, I want to kind of come from here to here. This is on the upper part. So what my plan is essentially weld a piece here, and we're going to kind of make a U shape, uniform U shape, to bridge that gap. That way that CV axle will still be kind of out of harm's way if we kind of run over a sharp rock or something. Plus it'll tie to both ends, this end and this end together. Once again, this is all kind of gusseted inside, so I don't think we'd ever have a problem with it flexing or twisting, but it will add a little bit more strength there, so we're going to go that route. So I think what I'm going to do is just take the plasma cutter and kind of cut the shit out of it. Check it out. We actually got the lower control arm on. Everything's welded out. Just let me know down in the comments, like, where I'm a welder and a fabricator, roughly. When I'm like filling in these pieces and whatnot and doing like just welding on this, I just find it boring content. But maybe you guys want to see that. Maybe you guys want to see more in depth of that. Essentially to me, that was a very, very boring thing to do. But if you guys would love to see a little bit more in-depth fabrication on just putting in pieces and welding, I mean, comment down below and just hit me up. And if that's something you guys are interested in, well, that's something I'll make happen. But yeah, so I'm pretty happy with how that turned out. It's if you look here on your flange again, we have it's essentially perfect. I can adjust these just a little bit. CV axles aren't bonding, so I'm super stoked with that. Now on to the next thing, which is the shock hoop. So it's actually the very next day, and as you can see, first thing I've done this morning, I came down and just kind of tidied up a little bit. Unfortunately, I have a lot of stuff in a kind of a small space, so when I lose a lot of floor space, it kind of sucks to be tripping up over things and whatnot. But with all that being said, you guys have all been there before, I'm sure. But as you can see, went ahead yesterday and installed our hoop, installed our shock. So this thing right now is actually under its own weight, and super stoked on how that turned out. It looks really cool, I must say. And I like my CV axle angles. I love the CV angles. Essentially, there's no bonding. Everything looks really, really, really good. I'm actually really impressed with that. That came out great. So I think this really paves the way forward for us a little bit. Instead of fighting with a system that was just failing and it wouldn't have worked even if we spent another 3 weeks on that thing. So I'm glad we kind of went this route. Now the next thing that we have to do is steering. Now, as you could tell, probably when we were putting these spindles together, you were like, well, where's steering gonna go and where's your calipers gonna go? So let's just touch on that. Essentially, I wanted to keep the steering arm off of the knuckle just for the time being until I do install my steering rack. Another thing with the brakes on the Tirajet, let me just bring you back here. This is yet again a mess, but this is how these things always stopped. There's essentially an output shaft. You got your brake disc here, brake rotor, whatever you want to call it. And this locks up your gearbox, which in turn locks your back axle, which in turn locks chain sprocket, which in turn would lock your front sprocket. So that's how that stopped. I'm going to try to use that. I'm not sure if it's going to work out for me because, well, we have, 90 horsepower engine. We have probably a bit more weight right now. Along with CV axles, there's probably other joints and stuff now. I don't know if that's going to be sufficient enough to stop this thing. So I'm going to hold off on putting caliper mounts on our knuckles or spindles, whatever you want to call them. For the time being, we're going to try that route. Don't know if it's going to work or not. So let's just jump onto the steering, and I'll give you a little rundown on how the steering was set up here, because you got to remember that we're trying to keep this amphibious. We're trying to keep water out of the tub. So let me show you how they done it back in the 70s and 80s, I guess. And still to this day, I think they still actually make these things. So I think that's still the same design. I could be right, could be wrong on that thing. So let me show you how they done it, and let me show you how we're going to do it. Now this is the factory steering system out of a Tirajet. If you have a bone stock Tirajet, more than likely this is what you're going to see. Of course, this is your steering shaft. Your steering wheel goes here. This piece here actually connects to the tub at a higher point than this rack, obviously. These two units right here, they're just bushings and seals. If you look really closely, there's actually a spot cut out here for a seal to be recessed in, and that's what seals up against the tub. Out in this outer portion, it's a brass bushing, and that's what this steering shaft actually rides on. As you can see, we have a rack and pinion, very simple setup. This gear meshes with that gear, and that's essentially how that turned in and out. Now you have to realize, this is pretty straightforward. This worked for years and years and years, of course. But being that we have so much travel in this suspension now, not sure if this would have worked for us. Now, in previous videos, I spent a lot of time trying to set this up, but once again, it was just working against myself because of the spindles, because of the suspension setup. It was essentially just a bunch of time wasted instead of doing it the right way, I guess. Now, I feel that if I would have put this back in and probably spent a little bit more time on it, especially with our new steering knuckles and spindles, whatever you want to call them, I think we would have been able to get this to work. But I'm going to go a different route. I don't think I'm going to go this route anymore, just for the simple fact that it may seem a little bit wore out. I do have new bushings and new seals bought for this, but I'm going to cut this in half, essentially having 2 points. I'm going to just have one seal face, essentially. Let me show you how I'm going to do that. So what I actually done, I went ahead and bought one of these cheap steering racks off of Amazon. This steering rack is essentially what you would see in a buggy, probably a small go-kart, or even a golf cart. The cool thing I like about this, one, that it's all sealed. We have a nice seal face here, and it's actually probably about a 3/4 turn to lock. Essentially, that'll make this thing really responsive, really quick. So this is what we're actually going to try to use to steer our buggy. Now you may be thinking, well, how are you going to get this to seal? Well, I've come up with this sort of bracketry. Now as you can see, I have a hole right in the center, and this one actually came with this little dust cap. So this is kind of what I have envisioned in my head. Of course, we're going to have to cut the front part of the buggy up to mount this, but I'm going to kind of show you what I have in mind here. So this is actually going to fit very tightly in here. I already went ahead and made this up, and I have it really, really snug. Now, what that allows me to do is to have one hole entering the tub as opposed to having two for that shaft to slide on. Now, as you can see, we have our dust cap is sealing that hole fairly well. Now I will just come in here with my steering shaft. It'll mount there. We still have enough for the bolt to kind of go through and lock it in, but that's going to be the seal point now. Now, another thing that I've done here, as you can see, I've cut these tabs out of 1/4 inch material for the simple fact I want this to be really rigid. This is what's going to be steering and holding this rack in place, and it's also going to be a bash point. This is essentially going to be a skid plate now to cover this and to safe it out. So I have to come in here with another piece of plate. I've made up these other little tabs like so. That's going to mount to the other plate. It's going to sit here like so. We're going to weld them to the other plate. And what this is going to allow it to do is shove this rack really tight against that seal. So I'll have the face and I'll have that piece of rubber protruding through here to seal from letting water in the tub. Now that's my theory. I don't know if it's really going to work. You have to realize we're not making a boat with suspension. We're just kind of making an amphibious capable buggy. So even if we do get a little bit of water in here, I'm going to add a bilge pump to this buggy anyways, because all Argos, essentially anything that's amphibious, have some sort of bilge pump. So I don't see any reason why this one can't as well. But I don't think we're going to have very much water come in through there. We're a little bit higher up. We're still going to be immersed in water when we are in water. But I think that will be a very tight seal. So what we have to do, I have to go ahead, cut a piece of plate, mount these. So then these will definitely go there like that, and just kind of sandwich all that really tight. It'll keep it from shifting, of course, but for the most part, these tabs here are essentially just to shove a little bit of pressure on that seal face and keep it sealed from the elements, aka water. Man, that plasma cutter. I love the plasma cutter, but man, it's so smoky. Oh no, is there a fire? All right, whatever. Anyways, this is essentially what my plan was. As you can see, I came in here with the plasma cutter, cut all this out, and now I just have to weld it in a bit more solid, and our steering rack will go there. Then our hole, is right there. That'll be where that kind of comes out through. So I think that came out good. Now, all this, I think I'm going to cut this out. I was kind of debating if I was going to try to weld all this, but I think for the extra bit of work, I'm just going to cut this out, make a new piece, probably just at a 1/8, just call it done, and weld all that in solid, as opposed to just trying to work in around all this. Anyways, that's at a later date, but this is what we're up to. All right, so guys, I went ahead and burnt all that in. As you can see, we burnt all this piece in here, came around the side, burnt there, and inside kind of looks like this. So this is the enclosure that sits in. Now, of course, this is where the original shaft went out through the tub. Have to repair that in a future video, but for now, this is where we're at. So this piece of plate here with the 4 bolts, this actually has those 2 tabs that I spoke about before. That's shoving in against our steering rack. It's a job to see in there now with the lighting, but it's shoved in against the steering rack. In turn, right here where this shaft, output shaft of the steering rack comes out, it's sealed. Essentially that rubber dust cap that I was talking about earlier is kind of flush, sits out there flush. So I believe that's going to be a tight enough seal for what we need. So of course this is kind of like a little skid plate. I may change that out in the future if I feel like it's too weak. It's 1/8 thick. It'd be nice to have some 3/16 there. The reason I didn't go all the way over and all the way over is because that's the only piece of scrap that I had left over this size. So we made it there. We made it this size. Went ahead and just put our steering in. This is very janky setup. I never took any footage of that because we will be touching on this in the future and making that oodles better, because it's kind of, I don't know, I'm not happy with it. It's janky. Now this is the factory tearjet bar and this is the factory tearjet. I think I can get away with like one nice piece of steering linkage. I don't need this linkage in the center here or anything like that. I think I could just get away with one down here to this universal type thing, and that's all. I don't think I have to go with this one. But if you look at it through the front, you can tell that it's kind of offset. These tearjets were actually 3-seaters, if I remember. You were supposed to get 3 full-grown men in a bit of gear in here and still be able to float. So hopefully by adding all this weight, we still have enough buoyancy, I'm hoping. There's a couple more things that I'd like to get kind of touched on in this video. I think I'd like to lay the body on there and just kind of make the clearance for there. I kind of hate cutting the body, to be quite honest with you, is because after doing a bunch of research and after seeing a couple more tearjets around Newfoundland, that was probably one of the nicer bodies that I've seen, believe it or not. And kind of breaks my heart to cut it up like I was cutting it up now, because I figured I'd be able to replace it, but it's not looking very good. So I guess I'm going to be able to learn a lot of fiberglass tips and tricks with that. But yeah, as you can see now, if we turn our wheel, now, is that going to be enough stroke? I sure hope so. I'm going to be able to make a nice piece here now for that to bolt to. I'm not oblivious either. Like I know that's for like a golf cart or, you know, a small, probably asphalt buggy or something like that. So I don't know if that's quite up to the test, but for the price of them, if I can get, you know, a year or 2 out of them and then it's just buy another one, slide it in. If this one gives trouble, well, I guess it's a consumable part. So with all that being said, let's go ahead and throw the body on this thing. Start cutting. Man, I'm going to be itchy as shit. I hate fiberglass. I've never done a lot of it, but I guess I'm going to do a lot of it here. So as you can see in the time lapse, guys, I went ahead and cut this out, made some clearance issues here, got all this kind of cleared out so we can get our tube to come up through. It kind of sucks, like I said previously, about this body, but what I'll probably end up doing is cutting something nice out on the CNC table, probably some nice stainless, and kind of filling in as much as I can here and here. This lid, I think in the future, it might have a lid delete. I think what's going to end up happening is I'm going to end up making my own aluminum fuel cell. This here is where your factory plastic fuel tank goes, but right now we have a little bit of a clearance issue due to this. I'd like to put some extra tubing for bracing in here anyways, to tie this together, and if I do that I won't be able to utilize our factory fuel tank. So I think what we're going to end up doing is probably coming around with this measurement here, whatever that may be, probably stepping up and making an aluminum fuel cell. that's probably an option. I'm not sure if we're actually going to go that route, but it's definitely an option for sure. And then that way we can kind of get rid of this lid. Not that it's in super bad shape, but I did cut it up pretty good. So with all that being said, this thing looks badass. I'm actually really happy how this thing is turning out. I will address the elephant in the room. The girl is pretty wide, I must say, but I didn't want to cut my CV axles. Essentially, if you wanted to make this same type of setup and narrow this thing in and shorten it up, if you wanted to play with your CV lengths, you can get this thing kind of narrower. Even if you wanted to play with different spindle angles, and you could probably change back spacing on my wheels and probably shove it in. But I wouldn't gain a whole lot, so I guess it's staying wide. Looks pretty cool anyways, in my opinion anyways. Maybe it looks a little too wide and janky, not sure. So, with all that being said, if you got to this far in the video, I really appreciate you. In the next video, we're going to be doing steering linkages, and we're actually at the point now that I can probably get the engine running and this thing actually moving under its own power. It'd be so great to jump in this thing, turn the key, and just drag it out of the shop instead of pushing it around. Now, with that being said, this is a liquid cooled 600, so we are going to have to figure out some sort of radiator, maybe some pre-runner radiator type thing. Not really sure what we're going to do there yet, because I'd like to be able to keep the radiator intact if I had to remove the body. It'd suck to drain the fluid every time I had to remove the body. With that being said, I don't really know why you'd have to remove the body from this point forward. You can essentially get at everything with the body on there. So I'm rambling yet again. Once again, guys, if you got this far, really appreciate you. If you can give us a like, subscribe, hit that bell notification. You're going to be seeing a lot more of this. I've kind of got the wind back in my sails now ever since I got this done. I'm kind of more excited about getting this thing up and running. So yeah, like I said, give us a like, subscribe. I really appreciate you. I'll see you in the next one.